Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 4-1 for October-November 2022 for questions 1, 2, 3. Question 1, coplanar forces of magnitudes P newtons, Q newtons, 16 newtons, 22 newtons act at a point in the directions shown in the diagram. The forces are in equilibrium. So if the forces are in equilibrium, that means that the resultant in the x is 0 and the resultant in y is 0. So we need to resolve the forces that are not on the x-axis and y-axis. So we need to put this one here, and you know that when we are resolving the forces, closing is cosine and then opening up will be for sine. So here it will be closing and then here opening for sine. So I usually draw a diagram here, and then I summarize my resolving of the forces. So I can put this one here. When we resolve 16 downwards, it is going to be 16, then the cosine of the angle 52. Then when it goes up here, it is going to be 16 sine of the angle 55. Then we also have Q here. Then this side, when we resolve the P horizontally, it is going to be P cosine of 25. And then when we resolve it vertically, it is going to be P sine of 25. So those are my resolved forces. Now I can simplify this. So since they said that the forces are in equilibrium, that means that what we have as the resultant in x is 0. The same for y. Now resolving the forces horizontally, we have seen that P cosine of 25 degrees is equivalent to 16 cos of 55 degrees and then plus the 22. So meaning P is actually going to be equal to 16 cos of 55 degrees then plus 22, and then we can divide by cosine of 25. So what does this one give us when we put in the calculator? We have 16 cosine of 55 then plus 22. Then down here we have cosine of 25. So this one gives us 34.4 to 3 significant figures. So P is equal to 34.4 to 3 significant figures, newtons. So that is that. Then when we resolve the forces vertically, we have seen that we have Q then plus 16 sine of 55. These forces which are going up, then we subtract this one which is going down. So this one is equal to P sine 25. Since we don't have the resultant in the y, let us just equate the forces. So meaning Q is going to be equal to P, which P is 16 cos of 55 degrees plus the 22, and then you divide by cosine of 25. I like using these exact values rather than using this rounded figure. So that is P then times the sine of 25 degrees. Then we shall subtract 16 sine of 55. Okay, so since we have our answer on the calculator for P, I'll just say that answer then times sine of 25. Okay, so what do we get from the calculator? So this one times sine of 25, then after that we shall subtract 16 sine of 55, and then we get our answer as 1.43 to 3 significant figures. So 1.43 newtons to 3 significant figures, and that is that. Question 2. Small smooth spheres A and B of equal radii are of masses 6 kilograms, 2 kilograms respectively, lie on a smooth horizontal plane. That means we don't have any frictional force. Initially, A is moving towards B with a speed of 5 meters per second, and B is moving towards A with a speed of 3 meters per second. After the spheres collide, both A and B move in the same direction, and the difference in the speeds of the spheres is 2 meters per second. Find the loss in kinetic energy. Now, if they ask for the loss in kinetic energy, that means the initial kinetic energy is bigger than the final kinetic energy. So I have my spheres here. They are of equal radii. So this is A, this is B, this one is of 2 kilograms, and then A is of 6 kilograms. Okay. Then we have this ground here. Maybe this is the one after collision. So what happens here? I have 2 kilograms here still for B, and then 6 kilograms here for A. Now, V here for A, remember they are moving in the same direction after collision. Now, the first one here, the U for A is 5 meters per second, and then the velocity here for B is going to be 3 meters per second. So if I take the speed, it will be negative because it is moving in the opposite direction. Remember, we are using the principle of conservation of momentum, which is the product of mass and velocity, not product of mass and speed. And you know that speed is a scalar quantity, and you know that velocity is a vector quantity and speed is a scalar quantity. So if they are moving in opposite directions, then that means we can put this one as negative. Okay, after collision, they are moving in the same direction. Now, since A is heavier than B and it is the one which is going to knock B, that means B is going to move with a higher speed. Look at the heavy object knocking a smaller one. It is automatic that the smaller one is going to move with a higher speed. So if I have V of A, that means V of B is going to be equal to the V of A, then plus 2, because they said that the difference in the speeds is 2 meters per second. Okay. Now, that means that when we now substitute in the principle of conservation of momentum, the mass of A times the initial velocity of A plus the mass of B times the initial velocity of B then is equal to the mass of A times the final velocity of A plus the mass of B times the final velocity of B. Mass of A is given as 5, then projected at the speed of 5. Then here for B, we shall have the mass is 2. Then the velocity here is -3. And then this way we shall have 6, then times, let's say VA, and then plus the mass of B is 2. Okay. Then the velocity of B is VA plus 2. Now we have to make VA the subject of the formula. This one is 30 minus 6. Then it is going to be equal to 6 of VA. Then we open the brackets. This is 2 VA, then plus 4. And then when I bring this one this side, so first of all, we have 30 minus 6, that is 24. Then 24 minus 4, that will give us 20. And then here we have 8 V of A. That means the velocity of A after collision is going to be 20 out of 8. And when we divide that, we get it as 2.5 meters per second. Okay. Then how about the velocity of B? Velocity of B is going to be this 2.5 plus 2, which becomes 4.5 meters per second. Okay. Then now we can go on and find the kinetic energies. Okay. So we need to find the total initial kinetic energy and then the total final. So total initial kinetic energy is going to be equal to, remember, kinetic energy is a half mv squared. Okay. Now we are going to have a half, then times this one is going to be for A and then also for B. So a half times the mass of A is 6, then the velocity is 5, so 5 squared, then plus this one of B is a half times the mass is 2, and then the velocity was -3, then we square. So this one will give us a half of 63 times 25, that will give us a 75. And then of course this 3 will go, the 2 will go. When you square -3, you get a 9. So when I add these two, I'll get 84 joules. Okay. Then we need to find the total final kinetic energy. Okay, it is going to be a half the 1 of A, then times the mass is 6 times the velocity. We have seen it is 2.5 squared, then plus the 1 for B, it is a half times 2, then this is 4.5 squared. So what do we get here? So we have a half, that is a half of 63, then times 2.5 squared. What do we get here? It is 18.75. So I write 18.75. Then how about this other one here? Automatically this will go. So 4.5 squared, what does it give us? 4.5 squared, we get 20.25. So 20.25, when we add here, it will actually be 39 joules. Now, the loss in kinetic energy is going to be the initial, which is 84, minus the final, which is 39, and we get our answer as 45 joules. Question 3. A constant resistance of magnitude 1,400 newtons acts on a car of mass 1,250 kilograms. Part A, the car is moving along a straight level road at a constant speed of 28. Now, if you have been following me from the start, we have always said that for constant speed, acceleration is always equal to 0. So find in kilowatts the rate at which the engine of the car is working. So if this is the car here, I always do these sketches to make things simple. So this car is having a driving force taking it forward, but then it also has a resistance force of 1,400 newtons. Okay. Now, for constant speed, I've said acceleration is what? 0. Now we have F is equal to ma. So the driving force here minus the 1400 then is equal to, of course this will be 0 because the acceleration is 0. So the driving force is therefore going to be equal to the resistance force. Okay. Then we know that power is the rate of doing work. Okay. And work is force times distance, then divide by the time. So distance over time is actually speed. So that simply implies that power is going to be the force, then times the speed. So that's why we write driving force times the velocity. So the driving force here is 1,400, then times the constant speed is 28. So then what do we get? 1400 times 28. This one gives us 39200 or 39,200. But then they have told us to give our answer in kilowatts. So that means I'm going to divide by 1,000, which becomes 39.2. So that is 39.2 kilowatts. If they have asked for the kilowatts, please put it in kilowatts. Then part B, the car now travels at a constant speed up a hill inclined at an angle of theta to the horizontal, where sine theta is equal to 0.12, with the engine working at 43.5 kilowatts. Okay. Now, we are going to look at this particle is now traveling up a hill. So this is the car which is going up the hill. There is a driving force, and then we have that resistance force, which is 1400 newtons. I want you to check the setting of the question. The stem is here for the whole question. There is a constant resistance force of 1400, and then A and B are under it. So that means that resistance is still there. So, but on an inclined plane, there is mg sine theta. Okay, so the m is 1250g, then sine of the angle of inclination. Okay, that is the horizontal component of the weight of the car on this plane. Okay, then from there, having known that, we are now going to look at, first of all, again, it is constant speed. That means acceleration is equal to 0. So using F is equal to ma, I can have the driving force here, then minus the 1400 minus the 1250 then the G is 10, and then the sine of the angle is given as 0.12. Then this one is equal to the mass, which is 0, of course. Okay. Then from there, we can see that the driving force is going to be equal to these two. Okay. Put this other side. So 1400, then plus 12500 times 0.12. So this one simplified, what does it give us? They said 1400, then plus 12500 into 0.12. So altogether, this one gives us 2900. Okay, 2900 newtons. Okay, but then they said that the engine is working at 43.5 kilowatts. So that is the power, and we know that power is equal to the driving force, then times the velocity. So power is 43500. You use watts, not kilowatts. Okay, then the driving force is 2900, and then we are looking for the speed. So meaning, making V the subject of the formula, we shall get 43500, then divide by 2900. And what does this one give us? So we shall have 43500, then divide by 2900. It gives us 15. So we shall write 15 meters per second. As simple as that. But see, on an occasion, the car pulls a trailer of mass 600 kilograms up the same hill. The system of the car and the trailer is modeled as particles connected by a light inextensible cable. The car's engine produces a driving force of 5,000 newtons, and the resistance to the motion of the trailer is 300 newtons. The resistance to the motion of the car remains 1,400 newtons. Find the acceleration of the system and the tension in the cable. Now, I'm going to again sketch. Okay, it is good to sketch, and then you put all the forces that are acting on the particles. So suppose this is my trailer here. Okay, and then it is connected to the car here. Okay, let me actually make this one a little bit longer. Then there is a driving force which is equal to 5,000 newtons, taking these two up there. Then this one is the car, and then this one is the trailer. Okay, now we have this 1,000. Of course, in this cable here there is tension. When it is taut, there is that tension takes the trailer up, but it is the same tension that pulls the car behind. Okay, then we have the mg, sine of theta. That is the horizontal component of the weight of the car, so which is 1250 g, then sine of theta. Okay, then there is also a resistance force of 1400 on the car. Then when we come to the trailer, there is a resistance force of 300 newtons, and there is also the mg sine theta. Okay, here the mass of the trailer is given as 600, so I will write 600 g, then sine of theta. That is, if this is the theta, the angle of inclination there. Now I'm going to look at the forces which are acting on these particles, okay, individually. So when you look at the trailer, of course, we are going to use F is equal to ma. So the ones that are acting on the trailer, we have T, then minus the 300, minus the 600, okay, minus the 600, then 10 for the G, and then the sine of theta, okay, and sine of theta is given as 0.12, okay, so 0.12, all right, here 0.12, then which is equivalent to the mass is 600, then times the acceleration. Okay, then I can now go to the car, or I can simplify this, and I say that I can actually leave it there. Okay, then let's go to the car. So what is happening onto the car? So we are seeing the 5,000 then minus, we have the tension, we have this resistance, and also mg sine theta. So those are the ones opposing the motion. So we are going to have minus the tension, minus the 1400, minus 125. Sorry, this one is a minus 1250. So times g, let me just write here 0, and then sine is 0.12, then is equal to 1250 of a. So to solve this one simultaneously, I will just add. When I add, the tension here will cancel with this one, and then I'll be left with only the acceleration to find. Okay, so when we add, the tension will go, and then we shall have all of these simplified. So let's put everything in the calculator and we see what we get on the left. So I have 5,000, it's the positive one. There is minus 1400, there is minus 12500 into 0.12, then there is minus 300, then there is also minus 6,000, okay, into 0.12. So altogether, this is 1080. So I can have 1080 on the left here, and then this other side, when I add 600 to 1250, we shall get 1850 A. So that means A is going to be 1080, then divide by 1850. So what is our acceleration here simplified? We divide it by 1850, and we shall get 108 over 185, okay? But I can write it to three significant figures as 0.584, 0.584 meters per second squared, like that. Then to get the value of t, I will come here and substitute in any of these equations, okay? I'll use the first one. So tension is going to be 600, then times this 108 over 185. I've killed the 0, okay? Then that is the acceleration. Then add the 300 when you take all of these this side. So we shall get 300, then plus the 6,000, then we multiply it by 0.12. So altogether, what is our tension? So we shall have 600 into 108 out of 185, then plus 300 into, then plus 6,000 into 0.12. And then this one gives us that value there. But when I write it to three significant figures, actually it will be 1370. So 1370 newtons. That is what I will have there. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content helpful, kindly like, share, and even subscribe. See you in the next video.